Hello, everyone. Welcome. Good morning, good afternoon, good evening from wherever you're joining us. I'm very happy to have all of you here today for our May Tech Talk. My name is Dalia and I work as a community manager here at Kong. We have Michael here today. He will introduce himself and he will talk to us about making Kong cloud native with the Kong Ingress Controller. Very interesting topic. We have a nice long demo for all of you. I'm excited for all of you to see it. We'll take all of the questions at the end, so please input them in the Q&A function that you will see at the bottom. And yeah, that's it for me. Take it away, Michael.
Thank you, Dalia. Dalia definitely stole my line. I was going to also say good morning, good afternoon, and good evening, depending on where you are in the world. As Dalia said, I'm Michael. I'm a director of product management here at Kong. And I'm currently the product manager for the Kong Ingress Controller, or KIC, as it's more commonly known. Now you might be thinking, what is KIC? Well, don't worry, I'm here to answer that. But first, I want to tell you a little story. This is Ashley, or Ash for short. And Ash, like many of us, spends way too much time on their phone. In fact, the latest time sync is a new photo sharing app. And this app is taking off. Like, they wanted to get it out quickly, so they built a big monolith or one language, all of their API in one app. But they're starting the monolith to microservices journey. And they're starting to split out some services, starting with users, their photo feed, and their ad system. Then all of a sudden, Ash starts to get errors when loading the feed. And then they get logged out because the user service is inaccessible too. It turns out that the new app's popularity is just too much, and all of this traffic is making their systems crash. What they need is an API gateway to help protect their services. So they install Kong, but unfortunately, this doesn't fix the problem immediately. You see, now that the app is pointing at Kong rather than directly at the feed API, Kong needs to know how to route incoming requests to the correct upstream service. If we don't tell it how to route requests, nothing will work. But how do we tell Kong that when you want to send a request /latest, that should go to the feed service? We need to add some configuration to Kong, and that gets stored in what's called a control plane. Now you might be thinking, like, control plane? Data plane? You didn't even mention that. What even is this? Well, Kong is split into two halves. A control plane, which manages configuration data, and a data plane, which receives and routes traffic. In some deployments, a single Kong gateway node fulfills both responsibilities. It handles your configuration and it routes traffic. But once you start to scale up, you tend to split these two out. We need to tell the Kong control plane what to do when it receives a request to /latest. We need to tell it to send it off to that feed service. Still with me? Excellent. Now, Kong offers multiple types of control plane, one of which is KIC. Now KIC, that's the Kong Ingress Controller, it stores configuration in a Kubernetes native way and translates that into a format that Kong Gateway can understand. It lets you use native Kubernetes resources like Ingress and the upcoming Gateway API. And the Ingress controller takes care of translating that to the Kong declarative configuration format. The Kubernetes native format is called a manifest, and an ingress is the standard way to configure routing in Kubernetes today. So what KIC does is it takes that configuration and converts it into Kong Gateway specific rules. So if we add this manifest to our Kubernetes cluster, where we're saying, if the request is coming to Kong.example, the path matches /latest, we want to send it to the backend service called feed on port number 80. If we apply that, when a request/latest comes in, it gets routed to the correct service. All right, so now you know what a control plane is and how Kik handles configuration. Now I just want to spend 60 seconds on why manifests are important. And the great thing about manifests are they're just text files. So that means that you can collaborate on them. You can have a review process. You can add governance. You can do anything else that you can do with text. It allows you to treat your configuration like you treat your code. You commit those manifests somewhere like GitHub, and once your CI/CD pipeline finishes running, the changes will be in production. This gives you a history of changes, the ability to roll back, and a ton of auditing capabilities. That being said, manifests are not the only way to configure Kong Gateway when it's running on Kubernetes. Kong actually supports multiple configuration options. You can use the built-in Kong Gateway control plane. This allows you to configure Gateway with the administration API using the Kong Manager UI or tools such as Deck, which is our declarative config tool. You might be thinking, but you can use Kubernetes manifests. Why do you need your own? And that's because Deck supports bare metal machines, virtual machines, and Kubernetes deployments. So if you're a business that has multiple deployment types, Deck might be a better fit. You could also use the Kong Ingress Controller with Kubernetes manifests, which I've already covered. Or you can use Kong's Cloud Control Plane, Connect. You can use, you don't have to use Kik if you're running in Kubernetes. You can use Connect whilst still running your data planes in a Kubernetes cluster. But it is important to note that data planes can only connect to one control plane. So there has to be a single source of truth for configuration. And that means that if you're using Kik, you couldn't use Connect. Until recently, that is. Because we've recently integrated Kik and Connect. We announced this at KubeCon EU a couple of weeks ago. And what this allows you to do is use the Kong Ingress Controller as your source of truth for configuration, whilst getting all the benefits of Connect. And I'll show you some of the benefits you get using a combination of Kik and Connect in a demo, which is actually coming up next. Now, this is going to be a pretty intense demo. I'm going to deploy a new Kong Ingress controller, show you how to configure an Ingress resource and send some traffic. We'll take a look at adding authentication to the API using API keys. And I'll even do a little detour into the Kubernetes admission webhook and the event system for when things go wrong. Then finally, we'll take a brief look at the Gateway API and how to configure the same route and authentication that I show you with Ingress using Kubernetes' latest networking resource, the Gateway API. So first thing I need to do is probably log back into Connect. No, it's still there. Excellent. So Connect has the concept of runtime groups, and a runtime group is like a virtual control plane. It's a virtual container for all of your configuration. And I'm doing this live. I'm doing it from scratch. So I'm just going to start with a new Kong Ingress Controller runtime group. I'll just call it Tech Talk. And when I click Generate, it gives me the instructions that I need to run in the terminal to deploy a new Kong Ingress Controller, some data planes, and connect it up to Kik, up to Connect. So I'm just going to download all of the files that I need and then head back to my terminal. So if I unzip the package that I just received, it contains 5 things, a TLS certificate and a TLS key. These are used for securing communication between your Kong Gateway instances and Connect, and then 2 values files, one for the Ingress controller itself and one for the data planes. These are used by Helm to actually deploy pods to Kubernetes. And then finally, it has some instructions, which are the same as these instructions. Now, I've done some of these in the past, so I won't be adding the choice repo as an example because I already have the latest one. But if I create a namespace, kubectl create namespace Kong, and then it asks me to save the certificates, which I've already got from the package that I downloaded. And actually, let's make this a bit bigger so we can see it. Then it asks me to create a secret using those certificates, and then run Helm install using the values files. So I'm just going to create my namespace and my secret. I'm not actually going to run Helm install yet because I'm going to do something special. So I show you values controller as an example. By default, Connect will tell you to install Kubernetes Ingress Controller 2.9.3. And for the data plane, we will get Kong Gateway 3.2. Now, you're seeing something special here. No one else has seen this. What I've done here is I've enabled analytics using Kik. So I'm using a nightly version of our Ingress controller. I'm using a release candidate for Kong Gateway 3.3. And now if I take a look at my config, you can see that's all been updated. This will allow me to see real-time analytics within Connect when I'm sending traffic through my Ingress controller managed Kong gateways. So if I now do the Helm installs, first I do a deployment for the Ingress controller, and then I do a deployment for the gateways. Now, if you're familiar with Kik, you might be thinking, why did you do two? I only normally do one. And this is because I'm using a new feature in Kik 2.9, which is called Gateway Discovery. So previously, the Ingress controller and the data plane ran together in the same pod as separate containers. Now, you can have a separate controller to your data planes. This means as you scale up your data planes, you don't also have to scale up the controller, which leads to lower resource usage in your cluster. All of those are running, which is nice. And I'm actually running a cluster in Docker desktop, so I should just be able to call localhost, and I can see no root matched with those values. It's definitely empty. I can call anything, and it will always return me 404. So now we've got 3 running Kong Gateway instances and a running Kong Ingress controller. It's time to actually configure it. The way that we configure our routing rules is using a manifest. And here's an example ingress that I've called echo, which when I make a call to /echo, it will forward it to a backend service called echo. Like, it's a lot of echoes, isn't it? It's like echo, echo, echo. Anyway, if I apply this, so KAF stands for kube control apply file. And if I apply that, then what Kubernetes will do is compile that to Kong Gateway rules and send it off to our running data planes. This is quite interesting. When something doesn't work, for example, we couldn't actually translate that configuration into something that Kong understands. It's because I've configured an ingress, but there's actually no service to send it to. So if I go ahead and create a service as well. This is just the standard Kubernetes service. An echo server is just something where you send a response, send a request, and it sends back what you sent as a response. And I've got a service and a deployment, and it's just an echo server written in Go that we maintain. It tells you what node you're running on, what pod, what namespace, things like that. Okay, that pod is running. The service is there. And because of the ingress that I created, I should be able to call localhost/echo, and Kong Gateway will route my request to the echo service. Just like that. So I'm on the Docker desktop node. This is my pod name. I'm in the default namespace. And it's all working. If I just send some requests, maybe some 404s as well, and then go back to connect, I should be able to go in and have a look at analytics. And here you can see all those requests I was just making. Like there's the first two that I made to /echo before the ingress was created. And then I had some successful requests and some failed requests. So I'm starting to get some immediate visibility into the error rate and the latency of my upstream services directly in Connect. I didn't have to configure anything. All I did was deploy Kong Ingress Controller and Kong Gateway using the instructions that Connect gave me. You can also build some custom reports. Here's one that I made earlier, where you can see a breakdown of HTTP codes. So turns out I did 5 of each. That was just a coincidence. But you can do interesting things like give me a bar chart grouped by service and then by status code. So these are testing runtime groups that I had earlier. But let me create that and change actually, let me change it to the last 15 minutes. We'll only get one service. And here you can see that we can immediately see all of the requests to our echo service port 1027 in the default namespace. And if there were different services, they'd all show up here stacked. So you can see the relative request count across all of your Kubernetes services. So we created a basic routing rule. This wouldn't have helped the photo sharing app because it would have just passed all the traffic straight through. So what I'm going to do this time is add authentication to our API. So the way that plugins work with the Kong Ingress Controller is you create a plugin definition. We have custom resources. This is a KongPlugin custom resource. And here I'm saying this is an instance of our key auth plugin. It's going to look for the header name API key. And this resource is called key auth. This could be called anything. We could call this apples. We just need a name to refer to it to later. Now, the important thing to mention is even though we've created this plugin definition, it's not actually doing anything yet because we haven't applied it to any of our ingresses. To apply it to an ingress, we add an annotation. So here I'm using a one-liner. You can also add it to your manifest, but I'm annotating the ingress called echo. And I'm adding the annotation konghq.com/plugins equals key auth. That can be a comma separated list of multiple plugin instances as well. So you can use, say, authentication and rate limiting on the same ingress. If I go back and make a request now, we can see that there is no API key found in the request. If I go back to my analytics, we can see that some 401 or unauthorized have started to appear as well. So the way that you provision API credentials in Kong is using what's called a consumer. You create a secret in Kubernetes that contains the consumer's API key. And then when you create a consumer, you tell it which secret to read from. So it's a generic secret. The Kong cred type matches the type of plugin. And then the key is a field that the key auth plugin reads. I'm actually not going to run this because I have it in this consumer.yaml. This is just base64 encoded credentials. It's just for user one with the key one. This part is important though. It's another custom resource. It's a Kong consumer. And we're saying that for the consumer with the username user1, we want to authenticate them using credentials from this secret. So if I go ahead and apply that, if I make my request, it still says no until I add that API key. And now things work. So just by adding a resource for a Kong plugin, in this case KeyAuth, and then annotating your ingress, we've actually secured our API using the same declarative tools that you're used to working with in the rest of the Kubernetes ecosystem. But this all worked. What happens when it goes wrong? For example, imagine that I provide an invalid configuration. So instead of it being key names, someone puts bananas in there. Oh, that's the wrong one. So if I apply the auth plugin rather than the consumer, we'll see that we got an error from the server when applying the patch. The server denied the request. It failed schema validation because config.bananas is an unknown field. This is life-saving. This is the Kong Ingress Controller admission webhook that validates consumers and plugins when you send, when you try to apply changes to a manifest, and it won't let you break a schema. Unfortunately, we can't do that for everything. So as an example, if you try and create an ingress definition with a root that isn't valid, say a regular expression root, and the regex isn't valid, we can't tell you that in advance at the moment. Fortunately, we've got deep integration with the Kubernetes event system. So if I run the field selector configuration apply failed, nothing's failed yet because it was caught with the admission webhook. But if I apply something that doesn't get caught, so for example, this, which uses this regular expression root, which looks weird. It is weird. It doesn't work. Like that is not a valid regex. Now the Kubernetes event system is saying, hey, this was an invalid regex. It's a PCRE error. There's nothing to repeat with store. So even though we can't warn you in advance, we can tell you almost immediately, like we couldn't apply this configuration. And nothing else will be able to be applied until you've fixed this ingress. So I'm just going to fix that ingress. so that everything is back to a known working state. So being able to run get events is kind of useful, but it feels very accidental. Like you have to be looking at the right thing. You've actually got to run kubectl get events yourself. What we really want is to push these errors off to something else. So during my testing, I actually landed on Loki from Grafana. Loki is a log and event ingestion tool. It takes a minute or two to spin up, but when it does, what it'll allow us to do is forward on all of the events from Kubernetes into Loki. And then within Loki, we can set up alerts that will notify us when something goes wrong. So instead of having to think, oh, let me just run kubectl get events, let me see if there is anything wrong, you can be proactively notified. So if I check the nodes coming up, KGPN is one of my aliases, kubectl get pods in the namespace Loki. If you work with kubectl a lot and you're not using these aliases, I highly recommend it. Just Google kubectl aliases. It's an open source project. It saves me a ton of time. So check the logs, kubetail. So there are no errors. That's a good thing. It's just taking a second to start up. There we are. And now it's ready. Now that we've got Loki, we also need to add something to the cluster to ship the events to Loki. And I'm going to use a project called Kubernetes Event Exporter. I'm using the Bitnami chart. It was originally started by OpsGenie, but it is now maintained by another company. This is the configuration that I'm using for the event exporter. I'm only looking at the two Kong specific ones. And I'm using the webhook receiver to send it off to my Loki cluster. So if I kubetail the event exporter, and then I try and apply an invalid ingress, nothing happened. This is the danger of a live demo. Let's go and take a look at Loki. Oh, I need to port forward. KPF, kubectl port forward, and I'm just forwarding the Loki service to my localhost port 3000. And I will also need to get my login. So when you install Loki and Grafana, it generates a password for you and stores it in a secret. Secrets in Kubernetes aren't really that secret unless you use sealed secrets. So I just base64 decode it, and now I can log in. No, nothing showing up for type kube event. All right, let's give things a kick. So let's delete the echo ingress and apply a new broken ingress. There we are. So now we're seeing it received an event. It's what we saw before, invalid paths, invalid regex. And when we go back to Loki, we can see that is showing up. Now, I'm not going to actually create the alerting rule for you today, but once it's in Loki, it's very easy to go from log message to an alert that can trigger on PagerDuty or get pushed to Slack or anything like that. The tool that I'm actually using, the Kubernetes Event Exporter, It can also push from instead of pushing to Loki, it can push directly to Slack. You have to be careful with that though, because of things like retries and multiple pods. I actually enabled it direct to Slack earlier and got 25 messages in 3 seconds because I had lots of Kong gateways all rejecting the config at the same time. So my recommendation is to go through something like Loki. All right, don't worry, we're almost there. We've deployed a Kong Ingress Controller and Kong Gateway. We've configured it with the Ingress resource. We've added authentication. We've taken a look at analytics. We've deployed Loki. We've deployed the Kubernetes event exporter. Like, that's a lot in the 15 to 20 minutes we've been doing this. I've just got one more thing to show you. And then we are done. So what I'm going to do is delete my ingresses. Nope. I don't need to write ingress. So kdeli, Kubernetes delete, kubectl delete ingress. Why is that not found? Because there are none. Excellent. I must have already deleted it. What I'll also do is delete the Ingress class of Kong. So the Ingress class is the parent wrapper for all of your individual Ingress routes. And now I'm going to start using the Gateway API, which is the next generation of networking for Kubernetes. To do that, I have to apply the experimental CRDs. So that will create lots of custom resource definitions for gateway.networking.kubernetes.io. And then I need to restart my Ingress controller because there's a feature where when the Ingress controller starts, if it doesn't detect CRDs, it won't enable that functionality. So that's now been running for 12 seconds. Yeah, we've been going exactly 20 minutes. It's not bad. The Ingress controller restarted, which means it should now be able to talk Gateway API. So if I call that, my echo route no longer exists. I deleted my Ingress definitions. It's just an empty Kong gateway at this point. So just like we had an Ingress class and ingresses, we have a gateway class and gateways. I'll show you what that looks like. So here, the gateway class tells Kubernetes which controller to use. In this case, it's the Kong Ingress Controller. And then it creates a gateway instance. And here it's just saying, listen on port 80 using the gateway class that we just created. You can add all kinds of listeners here for different ports and different protocols. Today, I'm just using plain old HTTP. Next, it is time to apply a HTTP route. Let me apply it, and then I'll talk through it. So a HTTP route is one of the types of route in the Gateway API. We've also got things like TCP route and gRPC route. But HTTP route is the one that most of you are going to be using, I think. And it looks very similar. Like we've got match rules. If the path starts with /echo, send it off to the echo service on port 1027. And it didn't work. Again, live demos. Let's have a look. Cannot list resource HTTP routes. So I saw this earlier when I was testing For some reason, a Helm upgrade fixed it earlier. Managed to a rollout for good measure. And things seem, so the Ingress controller is shutting down. All the works are finished. And then when it restarts, I should be able to use the Gateway API. There we are. So if I get the HTTP route, this is what was applied. So match a path prefix of /echo, send it to the echo service on port 1027. I'm not sure why I had to redeploy Kong Gateway then, Kong Ingress Controller. But if you hit that issue, if you want to deploy Gateway API CRDs after deploying the Ingress Controller, that is how you fix it. Now we're back to the point where I can make my request, but the final thing to do is to add my annotation again. So before, when I ran annotate, I ran kubectl annotate ingress echo. This time it's the same, but I'm just annotating the gateway instead. Except the gateway doesn't exist. So let's debug. The gateway is called Kong. Oh, is it the HTTP route that I annotate? Sorry, that is my mistake. It is not the gateway that I annotate, because it is not the gateway that defines the routing rules. It is the HTTP route instead. There we are. And now we're seeing our error message. And just like before, if I add an API key, things work as expected. Now, if I go back to my analytics, we see these requests just keep coming in. It's 5:40 p.m. where I am. We just had 3 failed and 3 successful requests. It doesn't matter if you're using Ingress or Gateway API. All of that analytics data is still available for you. Final thing, because I didn't really explain the power of Gateway API. From that demo, it looks just like the Ingress, so why would you bother changing? And once you start digging into the Gateway API, you realize it is a lot more powerful. The HTTP route rule gives you a lot more options. You can do things like query string matching by clicking this. So HTTP query param match, or you can match on headers or methods. You can do things like transform the request. So you can modify request headers. You can mirror incoming requests to additional upstreams and then just ignore that response if you're wanting to understand if a new implementation is performant or has the same behavior. You can implement redirects. You can rewrite the URLs. So if your external API and your internal API are different, you can actually configure that URL rewriting in your HTTP route definitions. What gets even cooler is you can configure those filters not just per HTTP route, but also per backend. So if you need to transform things for your V1 backend, but not your V2, the Gateway API supports that. And finally, backend ref. So something I couldn't believe when I first learned it was that to send requests across namespaces, you had to use an external name. It felt wrong to me. But the Gateway API allows you to use backend ref, which will expose services from within a namespace for use in other namespaces. So instead of having to have your ingress and service in the same namespace, you can actually start splitting those now with backend ref, but it is very much opt-in, so the owners of the service can decide who gets to call their services. I'm just scratching the surface on what Gateway API can do. I highly recommend going and having a read of the documentation. It's fairly accessible. You can just click in and see what is a parent reference, and it will take you straight there. What is a kind, the valid values or service and HTTP route. Like, it's all very well linked together. So yeah, recommend having a look. With that, I thank you for your attention. We did a lot today. We deployed Gateway. We checked out Connect Analytics. We secured an API. We took a look at the admission controller and the event system. We deployed Loki. We deployed the event forwarder. We even took a look at the Gateway API. It's a lot. I'm very happy to receive questions now, or if you've got questions later, I'm mheap on Twitter. Back to you, Dalia.
Thank you so much, Michael. That was amazing. Let's see if we have any questions. Anyone wants to ask something, now is the moment. You can post it in the Q&A function or in the chat, wherever you prefer.
I see Sajid has his hand up.
Oh, let me see. Sajid, you can ask your question now, live. Nope. All right, let's see. Oh, I think. Let's give it a minute or so. Maybe someone will ask a question.
I think maybe Sahil hit into too fast. Yeah. So what is the difference between this latest release? So Sahil's been using Kong for a while. If the question is, what is the difference between the latest versions of the Ingress Controller? That's very different to what the difference is in the gateway. I will answer both, starting with the Ingress Controller. The biggest differences are two of the things I showed you on this call. The first is the ability to deploy your Ingress Controller and the data planes, the Kong gateways, separately. This means that you can have a single Ingress Controller sending config to all of your data planes instead of having to run them next to each other. It's not too bad in a small cluster, but once you get a bit bigger, that actually saves you a lot of money, which people are very happy about. The second thing is the event system. There's nothing worse than things not working and you not understanding why. So being able to use the event system and be notified when something isn't working, that's key for me. Being able to just get a message saying, hey, there's an invalid ingress definition, please go and fix it, so we can carry on applying new routes. As for Kong Gateway, if you've not tried out the Kong Gateway 3 series, you're in for a treat. The biggest feature for me is open telemetry support. So being able to see where time is being spent in the gateway itself. So if you're adding things like rate limiting plugins and you're using Redis as your backing store, you can get an end-to-end span of all of that. So you can see how much of the time was spent looking up the consumer, how much of the time was spent going to Redis to see what the rate limit is, and how much time was spent in your upstream service as well, because understanding how your applications are performing are key. And Kong is no longer just this black box where you trust it works. You can actually inspect exactly what it's doing. Anonymous attendee. Terraform is in sync with this version. I'm not too sure what your question is, but I can hazard a guess. So the Kong admin APIs have been stable for many years. So there is no difference between the admin API between Kong 2.8 and 3.2 3.2. 3.3 is coming out soon. So any Terraform provider that you use for Kong will work in Kong 3.x just as well as it did in Kong 2.x. Sahil, is the doc available on the Kong site? Yes, it is. If you go to docs.konghq.com, you'll be able to click on the Kubernetes Ingress Controller and information on everything like the Gateway API. We have Gateway API examples and Ingress examples for a lot of things. So you can just click on the tab to see how to use it. We've got information on the event system, about gateway discovery, separating your Ingress controller and your data planes. It's all on there. So that's docs.konghq.com. All right.
All right. That's it for now. The recording will be uploaded on our YouTube channel if you want to rewatch it. Thank you so much, all of you, for joining, and we look forward to seeing you at our next events. Have a great evening, great day ahead. We'll see you soon. Bye-bye.
Bye, everyone.